Okay, we're going to learn a concept called a bearing. Let me get my pen. Okay, we needed to learn this bearing. I did get a lot of questions from several students, including some calculus class students, because it seems like a bearing is not a concept was taught in their pre-calc or algebra 2 class. So I just make this video to make it up. So bearing is something interesting that will help you to find the direction of stuff that you're looking for. When we talk about the direction, you know in the map, you know how to read a map. I assume you know how to read a map. So this is north, this is south, east, west. Okay. Think about it if you're like in the United States. I'm just roughly just draw that. And then you are a person standing right in the middle. Okay. Which direction is your north? It's up, right? When you read the map, of course, you show like up or down. But it's on the flat the flat surface. Okay, so this is north. So when we say the North Lakes, they are the North Five Lakes here. And then when we say East Coast, that's my East Coast, isn't it? Can you tell? That's East Coast. And we're leaving the West Coast. Here's the West Coast. And then we're leaving south. Ooh, somewhere around here. Okay, so you can tell. But now the question is, you are standing here. Here's your standing ground. Now just put a little point here. Okay, you're standing here. How can you tell someone here? Let's see, there's a little star here. How do you describe this direction? Where is this star? How do you find this little star on this map? You say, well, I can move north, I can move east. I gotta say, well, this is in my northeastern direction. True, correct. What about if there's another one? There's like a little cross. Is that also northeast? Yeah, but they're different. It's a little bit more eastern. This one is a little more northern, right? Okay, so we need to find a system to describe these directions, okay? And there are two systems. I'm going to give you the introduction of both of them, but we're going to focus on the second one. The first one is called um, azimuth. Azimuth. Do you know this term? Azimuth. It's called azimuth bearing. This one also have another system, another name. It's called a three-figure bearing. What does that mean? That means I'm going to use a three number to describe it. And for this system, if you want to use this azimuth bearing system, you always start from north. Always start from this north. And then if you want to describe something, for example, like this star, if you want to describe the little star here, you always move, look at what I'm doing. Okay, I'm going to move my pen from north, pointing north, and then I'm going to go clockwise to find the star. And let's say this is a 40-degree. Then how do you talk about this direction? That will be 0, 4, 0 degree. That is the azimuth bearing system. That's why it's called a three-figure. Even it's 40, but I have to add a 0 before that to make that to be three-figure. Okay, so it's a 0, 4, 0 bearing. What about here again? This is north. How do I describe someone exactly to my east? So that is going to be 0, 9, 0 degree. So let me just add a little n here. Make sense? Did you see this, the three-figure thing? Okay. So start from here, which is 0, 0, 0. North is exactly 0, 0, 0. And then east, 0, 9, 0. South, 180 degree. And then west, move again. That's a 270 degree. And then when you go back Don't tell me 360. 0, 0, 0. So this is a three-figure, 1, 2, 3 degree. In the system, start from 0, 0, 0 to 359 because we don't have 360. 360 is going to be exactly the same as the 0, 0, 0. Okay, so this is the three-figure. This is the three-figure azimuth bearing system. And the number is always starting from 000 to 359, 3-digit, okay? And no negative, and then nothing beyond 360 or nothing greater than or equal to 360. So it's cool, isn't it? Okay, let me give you a quick quiz. How do you describe 150 degree in bearing system? So you're going to go starting from here. This is your north, right? Okay, so you're going to move your, here, let me move that. Okay, so if you're going to move your pencil by 150 degree, which is this 90 degree? And then keep going, another 60 degrees, so it's somewhere around here. Okay, so that's right. So from here to here, or this direction, it's 150 degree. Basically, this angle is 150 degree, right? Yeah. So let me ask you another one. 225 degree. Where is that? So starting from here, you keep turning, and that's 90 degree, 180 degree, right? So 180 degree, you're going to move another 45 degrees. So there you go. This direction. That is a 225 degree. It's not bad, isn't it? Okay. So after we learn this azimuth system, we're going to learn another one, which is more important, I think. People frequently use the other one. Okay. The other one is called quadrant. Q-U-A-D-R-A-N-T, quadrant bearing. What does that mean? You probably have learned this quadrant, right? Did you remember when you learned this? The x, y coordinate plane. You have these two axes. You have the origin and you have the unit, and you already set up a very good coordinate system. And this is the quadrant 1, quadrant 2, quadrant 3, and the quadrant 4, right? Because you break this surface or you break this plane into 4 different quadrants, right? And the quadrant bearing take exactly the same idea, and then again we just use north, south, east, and the west. All right, and then we are going to start with a vertical line all the time, whether it's north or south. Depends on whether my final direction is in the quadrant 1 or 2. If it's in 1 or 2, the angle go from here to here, or from here to here. I'm going to start with north, okay? If it's under that, I'm going to start from south. So this quadrant bearing system, when you describe that, you should have a letter, could be either north or south. Should be one of these two, okay? And then you're going to move, right? You're going to move to either west or east, east or west. So either west or east. I don't know which one, right? Okay, but then inside should be an angle. Now the key is if you notice that you move from north all the way to here, and what's the angle? The maximum value of your angle will be 90 degrees. The minimum is 0, right? Again, 0 all the way to 90, okay? So 0 all the way to 90, and then 0 all the way to 90. How do you describe the angle which is between 0 and 90? Acute angle, isn't it? So here got to be acute angle. Okay? Sounds good? All right. Now, keep going. I want to ask you this. How do you describe this little star if this angle is a 40 degree. How do you describe the direction of that? So north, I keep writing this. Actually, you will be very familiar with this. You're going to know this. So how do you describe this direction? That will be n 40 degree east. There's no any other way to do it. That's the only way. So every time we use the n 40 degree e, that will be from north, and then you're going to spin or turn to east to this direction, which means the clockwise direction by 40 degree. You'll find the direction. Okay? And what about here? What about this guy? This guy, I have a little, I don't know, I have a little boat. Is this the right way to do a boat? And here is 20 degree. How do you describe that? Don't start from east, start from south. Always start from this vertical line all the time. And again, because it's under this line, so we're going to start from south, not north, okay? So it's going to be S, and what is this angle? That's 70, isn't it? So it's going to be S 70 degree east. Got it? So that's a bearing. Okay, that's a quadrant bearing. Okay, what about the west? Okay, someone, let's see, there's a flower. There's a flower here. How do you describe the direction starting from here, which is there? You can either move from north, go 90 degree to west, or from south, 90 degree to that. So you can say either. There are two ways to do that. One is n 90 degree west, or s 90 degree west. Either one. Okay, both are correct. Both are okay. But this has to be like a 90, okay? Cannot be beyond 90. If it's beyond the 90, then it's going to go to there, and then you have to start from north only. How do you describe north? See, you just like you start from here, and you're not moving, right? That's north. So it's going to be n 0 degree. Now the question is, I'm not moving, so you're going to do this, west or east. Okay, very similar. How do you describe south? It's going to be S 0 degree, either west or east. It doesn't matter. As long as you see 0 degree, that means you stay at the south. So that's this direction. So by using this quadrant bearing system, you can describe any direction. Okay, what about here? Let's see. There's a, I don't want to put a star flower. There's an apple. There's an apple here. So can I ask you, can you tell me the bearing of that? Yeah, so you connect that, and you figured this angle, that is a 35 degree. So how do you describe that? It's going to be n 35 degree west. You get that? If you get that, super good. It's not bad at all, right? The next question, how do we use this bearing system? If I tell you I'm going to use that to find a boat, would you be happy? I don't know. Let me give you one example. Okay. Let's say here is the starting place. That's your boat ramp, okay? So your boat is starting from here. All right, now, first of all, as the first step, your boat travel, step 1. Your boat travel N42E, 25 miles. Let me travel a little bit more. Can you tell me where is your boat? I give you the direction, I give you the distance, and this is the surface, right? So can you find it? Yeah, N42 degree E. So that's an N, and here's E. So I'm going to go N42 degree E. Make sense? So see, there's an N, and then I'm going to This is E, right? So 42 degree, which is about here. And then the length is 25 degree, 25 miles. Hey, that's my little boat. I can find it. Now you see how I use it? Yes, I use the bearing plus the distance to find the boat. Now, you are the captain, okay? So after we find you, you say, oh, I'm going to run away. So you're going to make a right turn, which is a 90-degree turn, and then you traveled by, let's see, 60 miles. And then you stop here. You think I can find you? Okay, let me ask you two questions. Step 2, I'm going to make a right turn, 90 degree, and traveled for 60 miles. Okay, I ask you two questions. What's the distance? I mean, how far are you away from me? Second, what is the bearing? Okay, now the distance is fairly easy to find. Where's my ruler? Keep losing things. Oh, here. Right, so I'm going to connect that. I just need to find what is this distance, right? And then because this is the right triangle and we have the Pythagorean theorem, a squared plus b squared, a squared plus b squared equals c squared. So in our case, I just remember that, okay? In my case, it's going to be 25 squared plus 60 squared equals d squared, okay? So let's solve it. 25 squared is a 625. 60 squared is a 3600. Which is a 4225 equals that d squared. Therefore, my d equals 65. D is 65 miles, so that's 65 miles. So what is the distance? You are 65 miles away from me now. What is the bearing? Which means what direction? Okay, so here is a 42 degree, right? And here's 90 degree. If I could find what is this, then I will find this because these three angles will add up to 180. How can you find that? For this one, this is the triangle. Therefore, if I assume this angle is A, then sine A will be the opposite is 60 over the longest is 65. Therefore, A will be sine inverse or arc sine 60 over 65. Now I'm going to get my calculator to do it because I cannot do this. All right. Now here is the calculator. And because I'm going to need to use the inverse function of that, so I have to click B. Second, did you see that? You got to sign that. So sine inverse, which is the arc sine, and you have the parentheses. Inside of that, you put a 60 up, 60 over 65, and then close the parentheses, equal. Very good. I got a 67.38 degree, right? Of course, I cannot do this in my head. All right, so if I get A, can I get this angle? Yeah, that angle is 180 degree minus a 42 minus a 67.38 degree. Okay. If you like, you can use calculator, but I can do this because I can do this by my head because this is 109 and then 180 minus that. So I can get that is 70.62 degree. So here is a 70.62 degree. Okay. So once you know that, can you tell me the direction? Yeah, this is the south, right? It's in the fourth quadrant, so we're going to start from south and then move to the east. So that is S 60.67 S 70.62 degree east. That's my direction. That's my distance. So you know the direction, you know the distance. Can you find the boat? I mean, can I find you? Because you are driving the boat. Yes. So you know the direction, you know the distance. You can find the boat. This is how you use this bearing. Remember, bearing tells you the direction. It's very important, right? Because once you know this, later when you learn vector, that concept, the vector just the we call that magnitude. In this case, is like the distance, magnitude plus direction. Okay, so I think this is all for the bearing. I think that's everything you need to know.